Okay, so before I start, I would like to mention a few logistical details. The first one is, okay, I guess you are able to hear me. If you are not able to hear me, then please let me know over chat. So the few logistical details, the first is how you are able to run the codes. So there are two ways you can run the codes. The first one is, good, you can hear me. So the first one is, if you have Linux machine, I prefer Linux machine, you can do that. People run on Windows machine too, but honestly speaking, I don't know how to run on Windows machine. If you are able to find out, it's good. But the way I work on Windows machine is by setting up WSL on Windows machine and spinning off a Ubuntu backend, and within the Ubuntu backend, I do my work. There is another way. There is another way. So there are two ways I would be running my code. One is within the Jupyter notebook, another is from the terminal. So shell, right? You can see here, for example, if I say lsl, then I can see the directories here. But of course, I'm using Linux commands. So if you are not familiar with the Linux command, it's very simple. Ls means list all the files and folders within your parent directory. If you're not familiar, just do a simple Google search, you'd be able to understand. Otherwise, if you are more comfortable with running your code inside the Jupyter notebook, you can do that. But I would be using a lot of um, this terminal command. And for that, you can do one thing. I would quickly stop share and share my other window. That is this Google Colab window. So this is the Google Colab window I have here. You can rename it Google Colab demo ideas autumn demo autumn 2025 demo. So you can see that I have connected to the Google Colab. It's connected. And why I use the terminal? Because I want to run a Python file. A Python file is a Python script. A Python script is often represented as .py. And if you do Python code.py, it would run. So the way you can save a Python file from the Google Colab is by using this magic command, write file code.py. For example, if I want to save it in a different name, I can change the name demo.py. And if I click on this play button, then it would save the following contents, whatever is there. It can save the following content into, for example, if I show the content here, right now there is code.py and sample underscore data. There is a directory. There is no mention of demo.py. But if I click on this, and then again do lsl, that is the list all the files and folders within this directory. Within this directory, I would see that demo.py is created. And once this demo.py is created, I can execute it with Python demo.py, and it would give me the required output, because I am just showing the directory contents. And the way you can do that is by calling this listdir command. Okay, so you can do either way. Either you can execute a cell within the Jupyter notebook like this, you get the same output. Or the way I'm doing, in some of the examples, I would execute the Python file. You can save the Python file inside this directory, and you can execute that Python file from the terminal. Okay, so you are all set. Good. Now let me get back to the Jupyter Notebook. So today what we are going to do is we are going to study Python functions, not functional programming. I won't have time to go into functional programming, but I would say let me change it. Why functions matter? Let me change it this way. Why functions matter? So functions are essential in Python for several key reasons. Reusability. For example, the thing is, don't repeat yourself. You write a code and you would be able to use it again and again. That is the idea. And modularity and code organization. When you write the entire code in small blocks, it would be easier to maintain the code, reuse it in different purpose, call it from several other programs, and debugging and maintenance would also become easy because of the modularity and code organization. So let us take one example. Let us see how this reusability, modularity, and debugging and maintenance, this can be done. So for example, we are computing a price of a product. So this is the base price, and this suppose the GST tax rate is 18%. So it's 18%, and there is a discount amount that is ₹10. So how do you calculate the product price? You would compute the tax. That is the tax is imposed on the base price. You compute the tax, and you add the tax to the base price. You would get the price with tax, and then you would deduct the discount amount. That would give you the final price. That is the that is computed from this base price 100. So if you run this program, then the final base price is 108 rupees, dollar, whatever unit it is, right? So the thing is here, oh, I skipped it, sorry. So the thing is, here what you note is I have written the entire code one by one. There is no modularity. Everything is done within a script. The code is not separated from each other in the sense that all the codes are dumped in one place. There is another design of doing, writing this code. Computing each one, for example, the tax and the applying discount in this way. By this way, I mean I'm writing functions, Python functions. And when I write def, this is the syntax. The syntax starts with def. There is a colon. And within def and colon, what happens is the function name. This is the function name. And these are the arguments. So don't miss the colon. This is important. The syntax is important. And within, after this colon, this indentation starts. This is the indentation. The indentation means that this part of the program lies inside this function. Similarly, this part of the function lies inside this function. This is a different function. The first function is calculate price with tax. The second function is apply discount. And there is a third function that does the naming. Please pay attention to the naming. The naming should be done in such a way that the naming tells your peers, your collaborators, that what the function does. So the naming should be explanatory. So the format price, apply discount. When I'm calling this name, I know what the function is supposed to do, right? That should be the purpose of the naming. So what is important is that what is going into the function and what is coming out of the function. Function is returning something. So what the things that are going into the functions are called the arguments. What is getting returned are called the returned, the outputs, or whatever you are returning from the function to the main body of the script. So what is the main body of the script? This is the main body of the script. What it is doing? It is defining the constants first, the base price, tax rate, discount amount. And after that, what it is doing is calling the function. So what is this thing? These are the definition, function definitions. So this function definition doesn't get executed inside the machine. So this might confuse you, some of you who are not from pure computer science background. What do I mean by execution? Execution means this is like the blueprint. Blueprint means when you are building a house, you must have a design, right? So this is the design. The house is not built yet. House building is, I mean, equivalent to running this piece of code inside the processor. So running this code inside the processor happens when you call this function. So these two are different: function definition and function calling. Never forget this. This is where you are calling this function, calculate price with tax. And this is the function definition. It is not doing anything. It is not occupying any memory, the cache memory inside the CPU. It is not running inside the CPU. The function definition is just lying in a Jupyter notebook file or .py if you write in a .py. So it is just lying in a disk or storage or wherever you keep it. It is not occupying any memory or any space in the CPU. The moment you call this function, the function execution starts. So this way, if you split this code, this monolithic code into small pieces, that is the main concept of using functions to design your code base. That's what you should do. What is the advantage? The advantage is it becomes reusable. You can call the functions anytime from anywhere. The modularity helps you to organize your code, and debugging and maintenance becomes easy. Reusability is the topmost advantage, because you can, so here I am calling the function with certain amount of constants. Perhaps in a different notebook or different file, I would call the function with a different constant. So it would become easier to call these functions. So this is the idea. So this is how we write functions in Python. Okay. Good. So the next thing is calling a function when, so let me rename it, return.py. Look at this function. I have written two functions. By the way, is it visible to you, or shall I? Okay, this is a little bigger. Okay, so there are two functions. The first function is do this, and the second function is return this. Okay, inside this function there is this argument, that is a variable. That variable, what it does is that I'm supposed to supply a name to this variable, and the next command, the print command, would do this hello visitor name. Visitor name is supposed to contain some visitor's name, right? So let me call these two functions. So these are the two function definitions. They are not getting executed. I don't know, some spots are appearing because maybe you are moving your finger, and so the thing is, you are able to annotate on my screen. Not sure how it can be stopped. It happened in the previous session too. I don't have any issue, but if there are a lot of spots, then you might feel distracted. Anyway, so this is the visitor's name that I'm supplying here. So look, this name and this name is different. This name is supplying from the calling environment, and this name is Python functions internal environment that we call function scope. Within this function scope, this name is known as visitor's name. So this variable that is containing my name, Sujoy, and when I am passing it to this function, that value is contained within this variable, the visitors underscore name, and this function recognizes this quantity as visitor underscore name. So visitor underscore name and name, they contain the same value, this string, but name is known in the calling environment from where I'm calling the function, and visitor name is known is the function environment. So we call the environment a scope. So name is known in the calling scope and visitor name is known in the function scope. So this visitor name, when I'm printing it, so let me execute this function. Clear ad is Python 02 to this string. Oh, I didn't save it. Sorry. I should save it. So first it does is hello Sujai. So this is what gets printed, and then it prints none. Why it prints none? Okay, so let me execute another function, the second function. If I execute the second function, then if I do this, then hello Sujai gets printed. So what is happening? In the first case, so in the first case, when I'm executing this, this none is getting printed. But in the second case, this none is not getting printed. So in the first case, this none is getting printed, but in the second case, this none here, this none is not getting printed. Why it is happening? It is happening because in the first function, we are not returning anything. This return statement is missing. So in the first case, we are not returning anything. So when we do not return anything from the function, none gets returned by default. None. This none gets returned by default. Okay. But in the second case, we are deliberately returning something. We are returning a string, a sequence of characters. And that string is getting stored in message, mssg, this variable. And when I'm printing this, in the second case, this hello Sujai is getting printed. So the take-home message is when we do not return anything from the function, none gets printed. So be careful about this. Sometimes you are expecting to receive something from the function, but all you are getting is none. That's because you are missing. That's a typical bug I've seen in the codes, that people tend to forget returning the output from the function. If you do not return anything, none gets returned. So the question that you okay, so the first question was, somebody doesn't understand the meaning of name here and the meaning of visitor's name here. So the name is in the calling environment. Calling environment is this file 02 underscore return dot py. So what is happening is that when Python file gets executed, it executed top to bottom sequentially. So the first, this line gets executed. So this is a comment. So comment doesn't make any sense. So it would ignore the Python interpreter. It would ignore this. And then the control comes to this bunch of lines. So the control understands. So this is simply a definition of the function. So we are not calling the function, nothing gets executed. So definition of function, it updates itself that I have seen 2 definition of function, good. So the program starts, the control starts execution this point onwards, because I am creating a variable and I am assigning a string to this variable. So in CPU cache, this or the what shall I say, the CPU space, this variable gets created and this value gets assigned, and then within the CPU this function is called. This is what is called execution. This is what is happening inside the CPU. So the execution starts from here, because there is nothing to execute here. This is just the function definition. So in this environment, in this, I shall say scope. Scope means within the scope of this. This is called global scope, because this is the scope of the mother script, that is the return.py, 02 underscore return.py. So this global scope executes these commands, and they have the name as variable, message as variable. So all these variables exist in the global namespace. We call them global namespace. Global namespace means in the scope of, or in the environment of this .py script, we have the list of all these variables. But when I am passing the value to this function has a different namespace, and this function knows this value, the value I'm passing, and I'm calling do this. Do this knows the value as visitor name, visitor underscore name. So when I'm printing it here, so visitor underscore name, this function knows this visitor underscore name, and this function also knows that visitor underscore name has the value this string, because I've passed this string as an argument to this function. That's the idea. Is it clear? I hope so. So this is just passing the value to this function. Do this has this value that I passed from the main function. I mean the mother function 02 underscore return.py. Sorry, not main function, the mother script 02 underscore return.py. That is the mother script. That is the global environment, because that is calling all the functions. All the functions means these 2 functions, this function and this function. So the global scope is governed by this script, the script that is return.py, because that's what I'm running from here. And they have the script has got this list of names, list of variables names that I'm calling global scope, and the value when I'm passing to this function, it is storing the value as visitor underscore name, and it is using the value of visitor underscore name in the subsequent processing. That's it. Now the second thing is, somebody asked this question: what is the difference between these 2 functions? The difference is that this function is not returning anything, and this function is returning a string. So value gets returned from the second function, value doesn't get returned from the first function. So when nothing gets returned from the first function, none gets returned. This is the none gets returned. Okay, that's the idea. This function, I'm not passing any argument here. So within this function, so again here the what is the global script? Global script, or the global scope? Global scope is 03 underscore return.py. That is the global scope. Within this script, I am defining one function. I would call from this script. I am not calling yet. I am just writing the definition of the function. Within this function, I am defining 3 variables. And I am returning A, B, C. So this is the function definition. What it does is it creates 3 variables and it returns the 3 variables. Now, within this global scope, I mean within this 03 underscore return dot py, I'm calling this ABC. ABC. When I shall call the ABC, ABC would return these 3 values. I need to store them. So I'm storing in VAL. This is the variable in the global scope. These are the variables in function scope. Which function? ABC. What does it mean? It means ABC knows ABC. I mean this function ABC. Shall I change the name? Let me change the name. Demo return function. So ABC is known to demo return function. ABC is not known to 03 underscore return dot py. So 03 underscore return dot py can see val, but 03 underscore return dot py cannot see ABC, these 3 variables. Who can see ABC 3 variables? Only demo underscore return can see ABC 3 variables. Because again, in programming jargon, we call it that ABC lie in function scope. That means only demo underscore return can see and can know ABC. That's why it is computed here and they are returned from demo underscore return. But the moment demo underscore return returns those values and assign them to val, val is known to 03 underscore return dot py, because val is declared in the global scope, in the scope of 03 underscore return dot py. The question is, demo underscore return, can it see val? That's a home task. That's you are supposed to tell me. I would be asking you a few questions whenever it appears in my mind, and take a note, because those things would be helping you to understand. If I say everything, you won't be able to understand the thing. You should have to search, you should have to go through all the I mean the confusions and execute your code, do a lot of coding, I mean rough coding, and then you would get develop, I mean you develop a sense of what is happening, what is not. So if you just keep on looking at my code, you won't be able to understand. This is just the motivation. I'm giving you a learning path. So these are the things, this is how the flow happens. Okay. So the val, again, coming back to our discussion, val is declared in the global scope. Val is getting the results from demo underscore return. So when I'm getting val, so what is val is printing? Let us see what val is printing. Again, I would execute it. So val is printing this 2, 3, 4. Is it something you can? So there is someone who is saying that val will store ABC but as array. So array, I don't know if, yes, there is a data structure in Python that we call array, but that is not the correct answer. The correct answer is val would store as tuple. Why tuple? Because you see the first bracket. The first bracket denotes they are returned as tuple. Why? Because when you separate the string, separate the characters or separate the items by comma, it is known as, it is again, some scratch marks are appearing. It's distracting. Please don't do that. So the ABC, they when it's returning them, we call them packing the variable, packing the items into a variable. And when I'm storing it here, it is stored as a packed tuple. But you can get them individually by doing this XYZ. So when I am expanding, I mean, I can store them as a tuple in the val, but I can also receive the values as XYZ. We call it unpacking. So in here, it is packing and returning it. And when I am parsing it on the left side of this equality, we call it unpacking. So Python is smart enough to figure out that A would go to X, B would go to Y, and C would go to Z. So this is how packing and unpacking happens in the form of tuple data structure. So for example, if you now print it, the first bracket goes away. So we don't have the tuple anymore. We have individual values. So this is the basic stuff of how the I would say the return statements happen. How I'm still discussing the return statement from function. Okay. So the next thing is, oops, let me organize it this way: 0, 1, intro, more, more, more. 0 to arguments, and the 0 to arguments, 0, 1, these are default arguments. Default dot py. So look at this. This is an implementation of a function. So I would be gradually giving you harder examples. So this is a definition of a function that implements a utility. When, for example, when you are installing something, you get this kind of prompt that do you want to proceed next? Click write yes or no. If you want to proceed next, enter yes or write yes or y. If you're not, if you don't want, then enter no or n, something like this. So how you can implement that? You can implement that in this way. So proceed check, that is the definition, the name of the function, and prompt is what it does is that I mean you can write this way: do you want to proceed? So if you click here, I mean, so this is how you would execute this function. So if you want to execute this, so again, this is the function definition, and you need to call this function from here. So how you would call this function? This way. Do you want to proceed. So if you write this, so this string would be the value of prompt. So the prompt variable, the function, the first variable that I call the first argument, the first argument would capture this string. The second argument I didn't pass. Since I didn't pass the second argument, it would take this default value. So that's why I have named this named this script this way, default arguments. So this is what I'm teaching you, how the default arguments are mentioned. When I'm not passing anything, there is a way I can set the default values. So this is how I am setting the default value. If I'm not passing the value of this retries, then it would take the retries, how many times I would try it for. So if I don't want to do that long, I can set it, I can override it. I can override it, retries 2, just 2. And then this is a alert message or the guidance message. You can modify it. So this is how you do. For example, if I execute this function, 0, sorry, 0 2 arguments. Okay, the file structure got messed up. Now it's okay. Python 0 1. Do you want to proceed? So there are this many options: Y, capital Y, yes, this, yes. So different ways I can say yes. So let me write yes. And it returns true. So, and it, I mean, there is, in this part, it is returning to the calling environment, because when I'm returning to the calling environment. There's nothing to do. Nothing gets executed. But if I say no, then the false would get returned. But if I supply none of them, neither an expression or character that doesn't belong to any of them, then all these things start executing, and it would give me chance that invalid user response. For example, if I something like 8 doesn't appear here, please try again, 7, please try again. Do you want to proceed? So it gives me invalid, so it raises error, invalid response. So the maximum it allows is so I've changed the retries number. So retries number is 2 here. So you can make it maybe 10 or 1. That overrides the retries value that has been automatically set in. Any questions so far? So the examples are getting harder. Are you able to understand? Because I guess this kind of constructs have become clear to you, right? Because in it there's a tuple, and OK means the value I'm supplying to the prompt. OK is like the 8 or Y or the ES I'm supplying in the terminal. So OK stores that. You know the input. What is the what does the input do? Input actually, if you do not know, what input does, so when I'm executing this function, so input is showing me this prompt. Input is showing me the prompt. What prompt? The prompt I've given here, and that is passed as an argument, the first argument of prompt. So input is showing me the prompt. Do you want to proceed? And input is waiting for my terminal input, that means the character I am going to, or the word that I'm going to supply to the program. The program is running. The program has not stopped. The programming is running. So I can write Y, I can write no. So whatever I'm going to write, the moment I hit enter, input would receive that entry from my side, and it would assign to the variable OK. And OK would check this if condition. It would check if OK lies in this bunch of options. If not, then it would get into the next part. This bunch of options, again, for example, I entered 8. 8 neither appears here nor here. So it would go into the rest of the code. So make sure that you understand this, and then you, for example, I showed you how to run it in the Google Colab, and you would be able to understand how things are working. Any question? No, I cannot do the dry run. You should do the dry run. If you do not understand what is happening, just let me know. You can ask a specific question. For example, you have the line number here. Which line number you don't understand? Let me know. And then, because if I do the dry run, it doesn't make sense. You won't be, so you take it as an exercise, right? I won't be able to cover the entire stuff here. So what is your exact question? Okay, I would be waiting for you. So you can ask the exact question by mentioning the line number. The line numbers are appearing here. Where is your doubt? Where you are not able to understand? Line 14. So again, what I did, if I write 9, 9 doesn't appear here, 9 doesn't appear here. So if the 9, the value 9 that I am inputting, if it doesn't appear here, then the if condition would turn out to be false. So it won't, this part won't get executed. So the control won't get back to the global scope. Next, if OK in this, so 9, the value I'm entering, 9 doesn't appear here too. So again, this condition, this if check would turn out to be false. So again, this won't be executed because if is turning out to be false, 9 doesn't appear here too. So the next line that is going to be executed is retries. So retries is, I have set, for example, I have set here 1. If I do not set retries 1, if I allow the retries to be the default 4, then what would happen is that 4 minus 1 retries would be getting the new value 3. So retries would be 3. Is 3 less than 0? No, 3 is not less than 0. So this would become false. So no value error would happen. What would happen last is it would print reminder. Reminder is please try again. It is telling me 9 is not a valid quantity. So please try again. So let me try. Here I'm executing 9. Please try again. Please try again means 9 didn't appear here, 9 didn't appear here. So this statement, they are not getting executed. So I'm not returning to the global scope. But since the retries, I set it 1 here, so I should get another chance. So 1 minus 1, 0. 0 is less than 0. So this is something edge case. So that's why it's giving me another option here. So let me try 10 here again. So then again, it was 1 minus 1, it was 0. In the next attempt, I input 10. 10 didn't match 2. So 0 minus 1, it became minus 1. If minus 1 less than 0, yes, it turned out to be true. And it gave me a value error, invalid user response. So invalid user response was printed. That's the whole thing. So look, I did the dry run for you. Is it clear now? after you line number 10, what is the data type? Okay, I understand what you mean. Let me check again, line number 10. Okay. What is the data type? You tell me what is the data type. You have learned data structure, like list, dictionary, integer, float. What is the data type? Just a few minutes back, I told this kind of data type. Anybody who can tell me what is the data type? Tuple. It is not string. Tuple. Why? These are the strings. These are the strings. But these strings are separated by comma and inside this first bracket. And this is called tuple, a sequence of strings stored in tuple, right? A sequence of strings stored in tuple because it is stored in the first bracket, right? Okay. Those we were to keyword starts by. So look here. So these are different thing. I mean, so here is a more complicated example. The example is you have this positional argument. We call them positional argument, and these are the keyword arguments. Why keyword? Because this is assigned with a default value. So when these are assigned with the default value, and you may or may not mention. So here, look at this example, one positional argument. One positional argument means when you supply one argument, this gets assigned to this argument. This value gets assigned, this 1000 gets assigned to this argument. Why? Because all the other arguments have default values. So they don't need any arguments. The argument that needs the value is voltage, because voltage doesn't have any default value. If I write something like this, then it has got a default value. Otherwise, since it doesn't have any default value, so that means this is a positional argument. We call them a positional argument. Now, this positional argument is used as a keyword argument. That is also valid. That is also valid construct. And here, two keyword arguments, because since I am explicitly mentioning voltage equal to 1000, it makes sense. It is totally syntactical. It's not illegal construct. Voltage, this action. So when I'm using explicitly, it doesn't. I don't need to mention the other things like these. I totally can skip the other thing and the one I need to change. For example, this, right? Now, what would happen? So these two are easy to understand. So I already said that when I'm passing the keyword arguments, since I'm explicit, I don't need to maintain the order. So the voltage, it can appear after action. So I swapped these two, right? I swapped these two here. So these are a totally legal construct. What would happen if I write this? Is it a legal construct? Yes, it is legal construct because this one would get assigned to voltage. The first, the primary, not the primary, the positional argument. The positional argument would capture this, and then serially, they would be assigned. This one would be assigned with state, and jump would be assigned to action. So do this thing. I mean, break this code. Try in a different way. You'd be understanding what is happening. So all these are legal constructs. So if you do not understand a single, or if you think that why it is legal construct, it doesn't make sense, let me know with the line number. So the Vijit Bose says, sir, isn't input function return strings? Input function return strings, yes. Did I say something different? Sorry, if I said something different, then remind me, what did I say? Maybe I interpreted something in a different way, or maybe you. So if it is, so yes, what is wrong with that? Input does give you string, but there is nothing wrong. Oh, okay, I guess you are confusing. Perhaps I am supplying 9 or 10, something like this, a single digit or something like this. That's where you got confused. Oh, okay, yeah, okay is a string. So that's okay, I understand. Okay is a string, but when okay is searched in the sequence of the strings, then there is a match, then there is a true false situation, right? So okay is a string. Okay can be y, okay can be yes. So if y, okay is y, it's a character. If okay is yes, it's a string. If okay is something, maybe a b c d e f g h, then it is also string. So a b c d e f g h doesn't happen here, so the outcome would be false, right? Did I answer your question? So a string is searched within a sequence of strings. No, actually, yeah, I understood. That is not, I guess what the student asked, let me, okay, let me revisit that. Did I understand it wrong? After if okay in line, so the query is very complicated. In line number 10, what is the data type in O? And then why? So I don't understand the query now. So here, this is the tuple and OK is the string. A string is searched in the tuple. So thank you, Vijit, for making it explicit. So maybe there was some confusion. Yes, I understand now. OK is a string, and that string is searched in this tuple. Okay, so this is tuple, but OK is string. A string is searched in within this tuple. Yeah, that's a good question. Good observation. I should have mentioned that. But the last question was a little bit, um, I mean, written in a complex way, so that's why we didn't understand. Okay, so let us try going faster because a lot of things to cover. I don't know if I'll be able to cover, but let me see. So since in the interest of time, let me go a little faster, and I would try to give you some home task. I would make a statement that these are illegal constructs. These are illegal constructs. So I would tell you why it is illegal construct. Your task could be like this, like this. Your task could be to write here why it is illegal construct. Why? Again, here, your task could be to write why it is illegal construct. Why? So the first thing is it's illegal because positional argument, you cannot skip positional argument. Positional argument is required. So I didn't supply any positional argument. Okay. So here after keywords, after keyword argument, you cannot supply any non-keyword argument. No. So again, voltage is positional, but you are supplying it as a keyword argument, right? So after keyword argument, you cannot write this as a non-keyword argument. This is not allowed. Why it is not allowed, it's a little subtle. I mean, you need to understand why there would be some confusion from the interpreter side. So I would let you think over this. So machine help, this one, so it's, I mean, this is a clever, tricky thing, right? It doesn't make sense. It doesn't make sense because if 110 that has to be assigned to voltage, then again I'm assigning voltage, right? So there is no point, right? That's why it is illegal too. And it has the positional argument missing. That's right. Okay, good. So the next thing is we would go to 03 main, and here circle dot py this is, so I would let you understand what is happening. Import math radius equal to 5. This is just computing pi r square. I hope I'm right. Yes. So this is just computing the area of a circle. So what is the area of a rectangle? Rect dot pi. How would you compute the area of rectangle? Simple. Import. We don't need to import math. Just multiplication. A equal to 5, b equal to 10, and then you do the computation. But what is important now is compute dot pi. If I write compute dot pi and so circle dot pi, rect dot pi, if I write import circle as C, import rect as R, then I'm computing area circle equal to C dot compute area. So this script, it has got a compute area function. So when I'm importing circle SC, I can access all the members. I can access all the members of this script or of this Python file by dot notation. So this dot notation, we would come to that later in details why this dot notation makes sense. So when I write dot, that means all the members, like I can access radius, I can access this function too. So this is what I did, compute area, and since circle is accepting radius as argument, I can do this way. Okay, let me view editor layout split. Right. Certainly. So C dot compute area, it has the compute area, and I need to pass some radius. So I am passing some radius 2. This 2 is the radius. And I am computing area rect. Area rect, what is the area rect? Area rect is R dot compute area. And this is maybe 10 and 20. Two sides of the rectangle. And I am printing area circle, area rectangle. Okay. So I can compute. So it is giving me the area of a circle. It is giving me the area of rectangle too. So this is the area of the circle. This is the area of the rectangle. But please note, when I'm importing them, these files, the rect and the circle, all the files are getting executed. All the files are getting executed. If you do not believe me, then I'm putting a hello world version here. I mean, hello world print. And this hello world print would be printed if I see the hello world. So when I'm importing, all the entire file is getting executed. But if I don't want this kind of I mean the execution, for example, I can write something like this. I can use this function as a standalone, right? I can compute, for example, print for checking. Perhaps I try to check if my file is correct or not. 3, 4 compute area. Maybe with different 34, 40. I checked with different values to see if things are working. And if I do that, the irony is that all will be printed. All these things will be printed. But I don't want that. I just want to use this part, this function from the rect, and this part of the circle. I don't want the entire part. So the way I can stop doing that is the issue clear. Is the issue clear? Perhaps the issue is clear, what I'm trying to say, right? The way I can stop doing that is by using name guard. If name equal to and then put them inside them. Put all this thing inside them. I do the same thing here. Perhaps I've checked this too. Compute area, different circle radius. So what happens is that suppose I am checking if my circle.py is buggy or if it is okay, it doesn't have any issues. So when I'm executing Python circle.py, it is executing all this printing. It is printing everything. See this 3 values. But when I'm calling circle.py from compute.py, then they won't be printed because of this name guard. Let me show you. Python. See, only this gets printed. They are not printed. The reason is that this is the reason I had to show you from the terminal. All these things are very difficult to show from Jupyter Notebook. The reason is that when you execute a command from terminal, for example, when I am executing circle.py from the terminal, the double underscore name double underscore, it takes the value main. It takes the value main. That's why when I'm executing from the terminal, all these things are executed. But when I'm executing compute.py here, this function also has its own double underscore name. If you print it, it would print main here. Double underscore main, double underscore, it would print here. But when this compute.py is importing or calling, it is importing, right? Importing circle SC. When importing circle.py, this name double underscore name double underscore, it won't be main. It would be something different. Again, a home task. What it would be? Print it out and you would know. I won't tell you, but I can tell you that double underscore name double underscore, it won't be main. I mean, it won't be double underscore main double underscore. So this if check would fail, and that's why they won't get printed. And I would get these things as part of the namespace. This is a clever design that is done to use a Python script both as a standalone script. You can, standalone means you can call it from the terminal and execute it, and also import it in some other script. Import it in some other script. I guess it's clear, right? Question. Can you repeat line number 13? Perhaps in the previous session. Okay, so the line number 13 is you have to supply the positional argument. Positional argument means which doesn't have any default value, right? So when the positional argument, you need to supply the positional argument. Those are mandatory, though they do not have default values. So when you are writing this way, the first one would go to the positional argument. If there is another positional argument, then it would go to the second positional argument this way. But since we do not have another positional argument, so by default, this would be assigned to the first keyword argument. This one would be assigned to the second keyword argument. First keyword argument, second keyword argument, first keyword argument, and second keyword argument. This would go to the positional argument, because positional argument is mandatory. First positional arguments and then keyword arguments get, this is the order when you call the function. That's the thing. Okay, sir, can you repeat line 13? Sir, can you explain positional? Okay, I guess I did. Please let me know if you have any question. So here is the thing. You need to be specific in your question. Line number this, line number that helps. And you are doing that. I'm happy with this. You are doing that. Instead of asking me general thing, if you become a little specific, then it would make my life easier. Okay. I get, oh, okay. So another thing is that when I am executing all these things, there is a directory that I didn't actually include. I mean, I can delete this directory. I can delete this directory. And then if I do this Python, if I run this compute.py, it would appear again. Look at this thing. I mean, if you pay attention to this directory, 03_main, that directory, strange naming directory would appear. See? And also I verified there's $_name_ is main. That's why this is how name guarding helps you. But why this directory with the strange name is appearing? Anybody? So Shreyas has a question. In circle.py, yes, it is stored in cache. That's right. But so I'm not sure. Excuse me if I'm not pronouncing your name in the right way. Probrisha Bharadwaj. So Probrisha is in the right direction. It's bytecode. But my next question is, what is bytecode? Okay, it has a longer answer, but yes, you're right. It's a bytecode. So the thing is, for others, if I ask you if Python is interpreted language or compiled language, what is your answer? Maybe I should ask Probrisha. Is Python interpreted language or compiled language? No, Probrisha is right when Probrisha said intermediate. I guess by intermediate, Probrisha, oh, interpreted. Okay, I would tell you. But first, let me see what Shreyas in circle.py name would take the value main. But in computer, it would take another value, that same name. So sorry, Shreyas, I don't understand your question, but let me say that when you are executing compute.py from your terminal, this way, when you are executing Python compute.py, maybe I clear it up. Yes, when you are executing this way, the corresponding script would have its own double underscore name double underscore as main. But since it is calling circle.py, I mean, since it is importing circle.py won't have double underscore name double underscore as main. It would have different value. What different value? You can figure it out. If you print it, it would appear here. I mean, I can do that for you. I can do that for you. So see, circle.py has double underscore name double underscore as circle, the name of the script. That's why when it is not matching with main, these guys are not getting executed, right? Yes, that's true. We can import from other directories, but those are the advanced examples. Let me see if I can go there really fast. And where is the... So code base, there is something called 04 arg parse. So it would be important for you. That's why I'm mentioning this. 04 arg parse. Yeah. It has got a lot of application. So when you supply, again, it happens in the terminal. When you apply this kind of thing, for example, import arg parse, and then you activate a parser. So let me tell you what actually happens. Let me add, and then so here what is happening is that when we, for example, here I'm executing this 0101 argparse.py. Sometimes I can add arguments, for example, formal. This happens, right? Name, maybe Sujai, this kind of, or we add this kind of arguments, additional arguments. So the way you control this kind of arguments is through argparse library. So this is the idea. I want to give you a short example so that you know how to do these things. When you add the argument, for example, the first argument is this, the second argument is this. Lastly, you parse all these arguments. So this is the parser. So you activated the parser this way, and you do the argument parsing after you declared all the arguments. Next, what happened is that this way. If args.formal exists, if you do not supply the formal, then it would turn false. Then this would be executed. And if you supply the formal is used as a Boolean, stored true. Stored true means Boolean. So this is a syntax. So if you mention formal, then it would be saved as a formal, and it would it would turn as true. This would be getting executed. If it doesn't, then this would get executed. So your question would be, from where we get this dot name? Dot name comes from this name. Dot name comes from this name, and there are different ways you can use this function. For example, what you can do is that let me see. What you can do is that Python my name. So what it did is that it executed this because I didn't mention formal. I didn't mention formal as part of this. That's why it executed this. So it turns out to be false. It executed this. Hi there, this. But if I write formal, then formal gets stored as a flag, and then this gets true, and that's why it would get executed. Hello. This way. But if you want to know what does this function do, oh sorry, then this flag help would activate this description. This description, for example. So this is a simple program to greet a user by name. This is what I wrote here, a simple program to greet a user by name. So you would see a lot of these things, this kind of argument parsing in large codes. So it's beneficial if you know all these things. The last thing I would mention is, shall I mention this now or shall I mention this later? Okay, let me mention this now. 0.5 function as variable. Zero one if dot com. So the idea is, for example, def func or my square x return x. My cube x so if you do this thing, I mean, if you execute this thing, my cube 3 and cd total 0 clear Python 01. So if you execute this without surprise, you get 27. And if you print my square, you would get 9. But what I want to do is that I want to, if array, I want to store this function, but I can do this way. I store the value of my square. My square is a function. I cannot store a function, but in Python, that's what I'm going to show you. If F is my square. I'm storing the function in the variable f. So in Python, you can store the function and you can treat the function as a variable. For example, print if you supply this, it's a totally legal construct. It's a totally legal construct. For example, see, so you can store function as a variable. But what is more interesting is this: if array, you store the function in a list, and then you loop over this. For example, a value is maybe 10, and then for each function in if array new val equal to each. So what is happening is that this quantity, this variable is looping over this function array. It is taking each function at a time, and then it is executing this function while passing the argument 10. So it is executing on this value 10. So if we write print new val, first we would get the square, and then we would get the cube. Okay, so let us comment them out. Let us comment them out so that they don't interfere. Python 01. See, why it is important? It is important because when you would be learning machine learning, you would see that this kind of function array is used to store different kind of normalization. Normalization means mean subtraction, or division by standard deviation or the maximum value to make them 1. Various kind of transformation functions are chained together so that you can apply a sequence of these functional operations on the value, I mean the data point that you are considering. Okay. Okay, good so far. Any other question? There is a question. Sir, can we import the functions from other direct? We have covered this. Yes, you can. If yes, then should we mention the directory while importing? No, I would come back to your question. So just give me a moment. It actually it is connected with the, what shall I say, the class concept. If I am not able to show you the fundamental of the class, then it would be difficult for me to tell you how this can be done. Actually, this can be done this way. For example, import something like this: some directory dot some subdirectory dot some subdirectory, and then some file this way. But there is a concept called package. You need to declare it as a package, and there you have to create init file there. It's a little bit involving. So let me first what shall I say? Let me first cover the main material today, the object oriented, I mean the class concept, and then I will see if I can go there. Otherwise, it's no way I can I mean I can share the way it is done later. Perhaps I would upload a document. 06 plus Okay, so we are done with the functional programming, and then we would be going into the class concept. So, zero class. Mm, mm, how to turn it off? It's disturbing a lot. Anyway, uh, so yes, Arkoditya Bhattacharya, Arkoditya said that Python is predominantly as an interpreted language. That's true. It's primarily a interpreter, but it also does some code optimization. Since it does code optimization, that bytecode is created whenever the compiler fields are, I would say, interpreter. I don't know if a compiler is the right way of saying, but I would come to that. So what Python does is that Python does code optimization and creates some optimized code in the form of bytecode that is stored in the PyCache directory. So the question is Python interpreter or compiler? The answer is Python can act both, right? Depending on the application. Okay. So what is this object-oriented programming? Object-oriented programming is a coding philosophy. The primary application of OOP is to build large-scale systems. What is important here is that what we studied is the control would start flowing through the argument. I mean, control would pass through the argument inside the functional body. And I mean, what we have seen is here def some function, some argument a1, a2, and the control would pass through the body of the function, and then you'd get, if you have something to execute, and then you return the output. It's sequential, right? But there are applications where you need to combine data, and the data have their own functionality. So combining this data into functionality require a different kind of programming style. People call them programming paradigm. I'm not using hard words, difficult words. So let us say programming style, combining data with the functionality. And that is the basic idea of object-oriented Python. So the data in those objects are called as attributes, and the functionality that they hinge onto are called the methods. So we won't go into the details because I mean, all these things take almost a week of class, and it's very difficult to combine them into a 2 hours class, 1 hour each. But let me instead show you examples so that we can understand from there what is happening. Right. So for example, class account. This is the account, and I'm writing object here, which I would explain later. So This is the bank account of a customer. The way you initialize the bank account is this way. Customer name and then balance. This is how you initialize the bank account. When you go to the bank, when they initialize your or they start your bank account, these are the operations, or some of these operations take place. Care has to be taken that balance doesn't get weird values, because this way you can do all kinds of manipulation. You give error message, initial balance must be greater than 0. Yes. If somebody asks, or the user wants to know her balance, get balance, return self dot balance. So we must complete this self dot balance. If the check, if it is true that if the balance is correct, then we write balance. Let me complete the writing and then I would explain what is happening here. Self dot name of the customer. Here's the customer name. So these are very simple definition of a class. So the way it works is this. I told you that the data and the functionality, they are tied together. What is the data? Data is the customer name. This is the bank account, the blueprint of a bank account. This is the customer name. This is the balance with which we would open the bank account. And there is a uh, I mean, required check, sanity check, if everything is correct. If the check is okay, then the name, self.name, is assigned as the customer name. That is the data that we talked about. There is another data point, that is the balance. So these things you need to create the object. So what is the object? I would come to that. What is the object? So this is the design. This is the data we need. And this is the methodology. This is a functionality that is tied to the data, because we need the balance. So get the balance. There can be another methodology, that is deposit, right? So the customer would deposit money in her account. So how she would deposit? She would deposit by this amount. So if I pass this amount, again, there has to be a sanity check. Okay, I would come to that. Self.balance. So if a deposit takes place, then the balance would be incremented by the deposit amount, right? Now here, how it works, perhaps that would explain to you how these things works. I mean, customer equal to account, maybe AKRI, and the person starts with 1500 rupees balance. Okay. Now, if I do that and then I print customer dot get balance. So the way I call the functions inside this class is by using this dot. By using this dot, I can access the functions inside this class. Get balance. So account has no attribute balance. So what? Oh, so I did a typo. It's correct. Okay, so a lot of things are going on here. A lot of things are going on. Let us explain one by one. So the first thing is, when I am creating this account, what is happening? So the first thing is, this is again like the definition of a function. I told you, when a function is defined, it is just a piece of code lying in the memory. It doesn't run in the CPU. It doesn't occupy memory in the CPU. So it is just a blueprint of a house. House needs to be built. It is just a design of the house. So here, this is just a piece of code. It doesn't execute. This piece of code is known as class definition. This piece of code is known as class definition. When I am creating an instance of this class, instance means when I am creating something using this class that occupies space in the CPU, that reserves some space in the CPU, that runs in the CPU, that allows you to call functions in the CPU, that entity is called object. That entity is called object. So class is the non-coding entity, if you can think it this way, just lying in the hard drive or lying in the storage, not running inside the CPU. The class is that kind of thing. And this customer, when I'm creating this entity inside this CPU, that is called the object. Now the thing is, why I'm incorporating this? Why am I incorporating this? Because there is something called concept of base class. In Python 3 onwards, if I'm not wrong, in Python 3 onwards, all these classes are derived from this base class. You do it or not, all these classes are derived from this base class. So in Python, it is better to be explicit. There is a philosophy of Python. It combines 10 statements, 10 or something more. I'm not sure. So that it's called Zen of Python. So there is something called, it is always better to be explicit. So from Python philosophy, it's always makes sense to be explicit. So that's why I've written this. Otherwise, if you do not mention, still your object is derived from this base class object. Okay. Now the thing is, what is happening when I'm creating this object? When I'm creating this object, this function is getting called. So this function is called the constructor. So when the constructor creates the object, and it requires two things. One is the customer name, another is the balance. So customer name is AK Rai, balance is 1500. Look how the control is flowing. So I'm passing these two arguments. These arguments, when passed and when the object is created, this init function is called. This double underscore init double underscore, this function is called, and the customer name stores the the order is important, the first value. Balance stores the second value. So you might be wondering, what is the self doing? What is the what does it mean, self? So the self, any questions so far? Okay, there is a question, what is self? Sir, all programming languages are interpreters and compilers. An interpreter translates and executes a program line by line like Python, and a compiler translates the whole program into machine code at once. Let's see, that's true. Okay, sir, what is self? Oh, what is self? Okay. Everyone is asking what is self, and I was actually going to tell you what is self. So here's this thing. What is self? Self is actually this object, this customer. So whenever we call some method, this kind of method, so these are called attributes, right? Class attributes, because they are the data. What is this called? Method. Loosely we can say class. So when we call a method, under the hood, Python passes the object, this object, into the method, and there has to be a placeholder for that object. If you do not keep it here, it would give you, for example, you just print something, print hi. Sorry, it would give you error. Let us see what kind of error it gives. Let us see. I'm deliberately removing self from here. So it says account.getBalance takes 0 positional arguments, but 1 was given. It takes 0 positional argument because I'm not passing any argument here, but it is said 1 was given. So who gives that particular argument? It is Python under the hood. It passes self. It passes self inside inside all the methods, including the constructor function. So self is nothing but customer. So to make it more elaborate, I'm writing customer A. And then customer B. Sorry. AK Das or DK Das. So AKROI is one object. AKROI is one object. I mean the customer underscore A. AKROI is not one object. Customer underscore A is one object, the first object. And when I'm executing get balance, so customer underscore A is passed in the place of self. We need a placeholder to make room for that. So self is in this case, self is customer A. But in this case, when I'm executing get balance from customer B, from this object, in this case, self is customer B. In this case, self is customer B. So is this clear? So two things happen when we initialize this. Creates a new object instance of class account. So this creates an object instance. We call it object instance of class account. So this class is the blueprint. Using this blueprint, it creates an executable entity, that is the object. So two things happen with this. It creates a new object instance of class account, and it initializes its data by following this constructor function. So these two things happen. And self you are I'm sure you are clear about. Python implicitly passes a reference to that object as the method's first argument everywhere. It does it everywhere. In some places, for example, you have some small function that doesn't do any class specific thing, maybe something mm, some bookkeeping function, some trivial, maybe bookkeeping may be difficult for you to understand, some trivial function, and this you may pass some argument, and it just prints. I mean, I just want to show you that it doesn't do anything significant. But if you execute this, then Python would complain that what you are doing, I'm passing self to it. So to restrict Python from doing that, you can do what is called static method. Static method actually allows you to execute a function without passing the instance to it, and you can use for some trivial stuff or some bookkeeping stuff that is not related to the instance. Okay, but that is an advanced concept. I just mentioned, since you talked about self, I mentioned that what is self and get balance. Let me do that like before. Self balance, return self balance, like this. Okay. Okay, so the object-oriented programming starts with this class. Class is a design or blueprint for building instances. So let me be specific with the terminologies here. What is class? Class is a design or blueprint for building instances. What is instance? Instance is something that, I mean, executable entity, a constructed object of the class that exists in the CPU memory, the cache memory, whatever you call it. It lives inside the CPU, it gets executed. So instance is a constructed object, executable entity. Class is just a design or blueprint for building instances. Now, attribute is any object value, that is the customer balance, customer name, and method is the callable attribute. You can call it. Function can only be called. A callable attribute of the class is called a method. Right? So one thing is important here. Everything in Python is an object. Actually, when I was trying to show you this kind of thing, I should not say that function as variable. I should say function as object. Everything is an object in Python. Even function is an object. So if a function is an object, then I mean here, what is its class? If function is an object, what is its class? Def if class. So f is a function. So if you write the type a, so function derives from the class function. So function is a class function. Okay. Function has its own class. Again. So here, the three pillars that object-oriented programming stands on are encapsulation, inheritance, and polymorphism. Encapsulation is three pillars of One is encapsulation, data validation, and data integrity. Encapsulation ensures data validation and data integrity. Actually, what it means is you need to have getter and setter methods. I would show you what it means. Two is inheritance. Inheritance is the reusability of the code. And the last thing is polymorphism. One interface, multiple methods. Single interface, there should not be multiple interfaces. One interface, multiple methods. So encapsulation, a small example of encapsulation is something like this. Encapsulation demo class in cap demo. You should take care of naming the class. Naming the class, I mean, the class name should always start with the capital letter, uppercase. There's a convention. It's not that you would get error, but that's a convention. Setter. Def set value. Look, I'm not using an init function here. What would happen if I do not use an init function? Homework. You set the value of, you do integrity check, integrity check. For example, I was checking if the deposit is negative or not, because if the data is, if you allow the account balance to be negative, or I mean, if you do not keep the check, then all the hackers would have a free time. They would start playing with different things. So you need to check all these things. And also cell value equal to v. So this is how you are checking. Else print error message. I'm not being explicit here. We don't have the time. This is the setter method. You are setting the attributes with proper interface. What is the getter method? This is the data encapsulation. That means for data integrity, you write your own function. That is the idea of data encapsulation. Return self dot value. And you can write other utilities like def increment self dot value. And you can create object and play with this kind of construction, right? So attributes are traditionally set by setter method. Some attributes are set right when an object instance is created, and that time we use the init function. So that time we use the init function. Sometimes I'm just saying, sometimes self dot branch, sometimes we keep keep an object, the attribute empty. Perhaps we would set it some other time after verification happens, all these things. For that kind of thing, this kind of setter function is important. When you are setting it later, this kind of setter function is important. So what is the summary? Ensures data validation and integrity and data validation and data integrity, and you need to have your own getter and setter function. Inheritance. So inheritance is, I wrote the encapsulation demo. Inheritance demo date object. So let us remove this. We don't need this. Def get date cell return maybe 2025 08 28, and then time. Now I'm not writing object, I'm writing date. So the new class is derived from this date class. So this date class is called base class or the parent class. This time is called derived class or the child class. So this is the base or parent class, and this is the child or derived class. Now, if I write this get time cell, time is maybe 0 21 03, something like this. Now, when I would initialize the object date, then maybe print df dot get date. So we get something like this, right? But time get time, we get time like this. So df date and df time. So df, okay, let me execute once again. Df, okay, and df time, this is df time. Yes, but since time is inherited from this date object, time also has access to this get date. For example, if I write get date because of the inheritance. See, it also has access to this date. So since this time is derived from the date is the parent class, we have access to this method too. And that's why even if time doesn't have this get date method, df underscore time is able to access the get date method because of the inheritance. Why inheritance is useful? Reusability of the code. You don't have to write the code multiple times, right? Reusability, it's important. The last thing is, I would say polymorphism. Polymorphism is, so I would show you one example, perhaps with this idea. I won't write the code, just the idea. Polymorphism E1, employee 1, E2, employee 2, E3, employee 3. Actually, they are not employees. This guy is regular employee. So this instance is created from regular employee, but this instance is created from contractual employee. So all these are class definitions which I'm not showing. I'm just conveying the polymorphism idea. And the last is vendor service. Vendor service. So maybe here you write Joy, Ray. Maybe the ID is 111222333, and this is the salary. The next is maybe Anima Das. This is a different ID. The different ID because contractual employee, different ID 121 005 3001 1500 maybe. And since contractual employee should be paid at an interval of 7 days. Similarly, vendor service, when there is a vendor service, it's no more a person name. Maybe Hello World Limited. Hello World Limited. Hello World Limited. So let me remind you, what is polymorphism? One interface, multiple methods. One interface, single interface, multiple method. One interface, multiple method. 134,001. This is maybe they would start, this is the amount they would be getting at an interval of 10 days. Okay. So I have created E1, E2, E3, but where the polymorphism kicks in is here for E in E1, E2, E3, E dot compensation, E dot compensation. E dot compensation. Let me write once again. One interface, multiple methods. So we would see which one, regular employee, contractual employee, or vendor service is this. And the compensation, that interface is same. That interface is same. Within the interface, we will write the code that way. This is a little bit advanced concept. We would write the code that way that the interface means input, the input and the output, they would remain the same. Within that interface, I would take care of all the details. All the details, I would not expose them. All the details would be hidden, and I would take care of all those details. So that is the idea of this polymorphism, one interface, multiple methods. So Python has a lot of these things, one interface, multiple methods. For example, if you are not sure about the interface, I mean, how you design the interface, there is another, I mean, I didn't discuss it during the function discussion, but you can do this way. For example, you don't know what would be your number of arguments. What you can write is paths. This way, paths. paths means when you write this way, it means list of arguments. You can write as many arguments as you want, and I would access them for path in, or for p in paths, print paths. So this way I can access them. You can also do this. For example, arguments, keyword arguments, perhaps here I should something like this. So if I want to give a dictionary, if I want to give a pass the dictionary, look, I define the I'm calling the function this way. This is valid. This is totally valid, and I can write function this way. For example, I can write this function not this way, but this way. And the way I created this, maybe I'm confusing you. Let me write it this way. Def list as arguments, and here dictionary as argument. Dictionary as arguments. In that case, it would be double star. And within this you process all the dictionary elements. Why it's a good design? It's a good design because you don't need to change your interface. Two departments are talking to each other. If you keep changing the interface, then these two departments would start fighting with each other. You are changing the interface, as our code base has to be changed. So instead, what you do is that you keep your interface like this, totally flexible, and within the interface, you do all the detailed stuff. You don't need to tell the other that we are changing the things. That's polymorphism. Keep one interface, and multiple methods you do the details inside the method. You don't need to tell the outer world what is required. So that makes the code really scalable. Okay, so I don't have time. 9:15. Maybe I had some other things to discuss. Maybe some other day. I would see if I can discuss. There is another thing, that's operator overloading, and another thing is the yes, the overloading concept. The overloading concepts need to be discussed. Maybe someday I would sneak in and I would cover this small part. Any questions so far? There are two remarks yeah. So abstraction. So the whole thing is abstraction manifests in different ways. I mean, I see encapsulation as a way of abstracting away the details. Polymorphism also does the same thing. Do you have any other? So this is a good point. Good that you pointed it out. So do you think that I'm missing something, or this can be made more specific? Orkodipto Bhattacharya. What is self? I have covered this. What is self? Uh, let me see if okay. Who is present? Anybody from CEO's office is not present. Okay. I don't know if I can go ahead with the, I already um, crossed the time limit. I don't know if it is permitted. That's why I'm looking for someone from the CEO's office if I could ask if it is permitted. Or otherwise, what shall I do? So the one important thing is, for example, since I said that it's a Python is object-oriented language, everything is object. You can see, for example, if x equal to 5 and y equal to maybe Kolkata, then if you want to see if the type of this object x and then y, you can, oh, sorry, print type x and type y. So this is class int and this is class string. So everything is object, everything comes from a class, definite class. And if you want to know what are the methods, what are the attributes inside them, you can do that. There is a dir command, dir x. If you, so these are the methods. So these are the methods, and there is a specific meaning with this double underscore, double underscore. These are the magic methods. I didn't cover them. Those can be covered in the operator overloading, or when, if I had time to go into that, perhaps you don't need all these things. Maybe you need, okay, I will check with CEO's office and I'd explain all these things to you later. Okay. I guess I should stop here. Oh, so there is a question I didn't see, and it was a private message. When you enter, why it returns true, then why not takes another input? No, I guess you confuse the flow of control. So again, please view the session. If you have any question, let me know. Otherwise, it's good to have you here, and I would be sharing all these things with you. I know it's heavy duty because this functional programming takes a few sessions, and then so object-oriented programming takes another few sessions. So combining these two into one, because we don't have time. Maybe if you have any doubt, let me know. I would take another session. It's totally possible. No worries. Any question? If no question, then uh, we are going to wrap it here. Sir, what is the precedence order of operators, logical, arithmetic? Yeah, it's a good question. I mean, you can check it out. I, off the head, I cannot remember because it has to be memorized. I mean, you can check it out and you'd get perhaps, uh, if I say I would maybe saying with confused mind, I need to check too. But there is a precedence, and if you check, you would get, perhaps you can take it as a homework and you would also let me know what you get. Good. Uh, Sir, can you recommend some good resources for learning Python? Uh, okay, so what I usually say, let me share with you. What I usually say is this. Just a minute. Let me find it out. Where is that? This one. Let me share the screen. Let me share the screen. Yes. So this one, Python NumPy tutorial with Jupyter and Colab. So the idea is you have the basic data types. Everything is covered here. You don't need Jupyter and Colab notebooks. You already know this thing. Just ignore it. Python data types and the data structures. So Python data structures are this, Python data types is this, and functions, classes. So they didn't discuss in the details that I did, but it's good enough to understand what the what kind of functional classes you need. You don't need much for following this. The emphasis is on numerical Python. So NumPy, and then don't go to SciPy. It is not needed here and it is obsolete too. NumPy and Matplotlib. So these things are good enough. The Python data types, Python data structures, numerical Python, and don't go to SciPy. This is good enough. This is one thing. And another thing I strongly recommend. So this is level 1. In level 2, what you can consider is this. Check book. This book. This is totally free. This is totally free, and you'd get everything from here. So this is level 1. You do the level 1 stuff here, and in next stage you can consider this one. Okay, good. You can take a screenshot, or you would get the recording, right? You don't need to take the screenshot. You would get the recording. Okay, let me stop here. Okay, thank you very much. Any other question? I don't see any question. Okay, no. Okay. If you have any question, just let me know over email, or I can take a next session with you. Bye. Good night.